Okay, let's have Adam. Will you just read 27 for us?
It takes Ted 13 hours to harvest the field. Ashley can harvest the same thing in 8 hours. They work together how long does it take?
You go, Ashley. She's harvesting that field like no one's business, right? Ted, on the other hand, pick it up, Ted. All right. So now what we're going to do here, guys, is we want to figure this out. So if it takes Ted 13 hours to harvest a field, Ashley can do that same field in 8 hours. What if they work together? How much faster can they do it? So I'm going to go in here and I'm just going to put, okay, let's look at Ted. Let's look at Ashley. And then let's look at them working together. Now, Ted can harvest one field in how long? 13 hours. Ashley can harvest that same one field in 8 hours. So together, they can harvest one field in, we don't know, X hours. Alright, now this is actually going to be a blast from the past for solving. This isn't dealing with exponentials or logarithms, but it's just, we're throwing it in here anyway, okay? Okay, I want to solve for X. So we need to find the LCD. What's the smallest number 13, 8, and X all go into? Just multiply them together. What's 13 times 8? Is that 104?
Yes.
Awesome. So we're going to say, hey, the LCD here. Where are you, pen? The LCD is 104X. So if you guys remember the Chuck Norris notes, if you're solving a rational equation, you just times the LCD to all the numerators, and it will cancel out all the denominators. Okay? So 104 divided by 13 is going to be 8x. 104 divided by 8 is going to be 13x. And then over here, everything cancels, the x's cancel, so that's just 104. You following here? You okay? So now 8 plus 13, that's 21x is equal to 104. So if I divide both sides by 21, someone on a calculator help me out here. What is 104 divided by 21? What do you say? 4.95. So we're going to round that up to 5, okay? So if they work together, then they can get that field harvested in 5 hours. So these are called work problems, and they're pretty common in math, like in a class like this. So it's good to know how to set those up. Okay, now I want you to try to set up 29 on your own. It's just a little bit different, but try to at least setting it up with that same approach where you say, well, this person works alone, and this person works alone, and then total. And yeah, I'll give you about a minute here to try to set it up, and then we'll go through it together. Alright, so let's go over this one. We're told that if they work together, they're going to tar this roof in 6.96 hours. If Tim did alone, it would take her 15 hours. How long would it take for Eugene to do it alone? Eugene, that's a weird name. We should just call him Flynn instead. Alright, let's go over this. Hey, Hiram, tell me how you set this up. you say for Flint or Eugene? 1 over what?
Never mind. Oh, 1 over X.
Yeah, because we don't know how long it takes Eugene to do it alone, okay? So then we just have it like this, right? Okay, does this make sense why we set it up this way? Because we were told how long it take them to do it together, alone, so now we're just finding if Eugene were to do it alone, what it would be, okay? Now, what are we going to do next? What is the LCD going to be here? Yeah, it's going to be 15 times 6.96. I don't know what that is, so I'm just going to put them all together and write like this. An LCD is going to be 15 times 6.96 times x. And I'm going to multiply that to all the numerators. That way it's easier to see what cancels out and what's left over. So when I times it to the first fraction, the x's cancel. So guys, help me, what is 15 times 6.96? 104 point what? 0.4, thank you. With Kim, the 15's cancel, so I'm left with 6.96x. And then with the total, the 6.96 cancels, so I've got 15x. Is that looking right so far? Okay, so then what we're going to do is we're going to subtract off that 6.96. And I believe that would give me what? Help me out here. 8.04. Yeah? Okay, cool. Alright, so then let's just divide both sides by 8.04, and I need someone with a calculator to help me out there. 104.4 divided by 8.04, what does that give us for x? Like 12-ish. Okay, so basically 13. Awesome. So if Eugene were to do this by himself, it would take him 13 hours. Okay, so this is called work problems. I kind of forgot to go over them earlier, so I'm just going over them now so they're in your repertoire of math skills. Cool beans? Do you have any questions on it? Okay, and then lastly, we're going to do a distance problem real quick. Distance rate equals rate times time. Hey, there's this great video on YouTube. If you're ever bored, you should Google what is 80 miles per hour real meaning. Have you seen that video? There's this guy driving with his wife, and he asks her, if we're driving 80 miles per hour, how long would it take us to go 80 miles?
Oh, I've seen that.
You seen it?
Yeah.
I want you to think about that question for a second. If you're driving 80 miles per hour, how long would it take you to drive 80 miles? What do you think? 1 hour, right? Anyway, his wife is like thinking really hard, but she's overthinking it, and she's just like spitballing thoughts, and she can't get the right answer, and her husband's kind of teasing her. And I don't know if she doesn't know she's being recorded. He posts it, and it goes viral, but then she was really mad at him. But anyway, it's fun. You should just look it up. Okay, we're going to use, the reason you guys know that is because the concept that distance equals rate times time, this formula here, I mean, that's what we're getting, right? If I'm going 80 miles per hour, and I go, how long does it take to go 80, that's 80 miles per 1 hour, right? Anyway, when you're doing motion problems, this formula right here, distance equals rate times time, it's going to be pretty important. So I'm going to ask Allie, will you read this for us, 31? Alright, so what we have here, guys, is we have two situations. Cooper is riding with the wind, and Cooper is riding against the wind. How does that change your rate? If you're going with the wind, what happens? Pushes you so you go faster, right? If you're going against the wind, it is going against you, you go slower. So what we're gonna do, guys, is we're gonna look at the two situations here. One where we're going with the wind, and one where we're going against the wind. Alright, and we're gonna use our formula, distance equals rate times time. We're gonna break down this problem and find out what the rate is. Alright, now when Cooper is driving or riding the scooter with the wind, how far does she go? This is Mrs. Cooper, so that's okay. 30 miles, right? But against the wind it was only 10 miles. Now, the other thing that's really important here is that it's in the same time. So even though we have two equations, what do we know is going to be the same about both of them? The times. I want to highlight that there, okay? Okay, let's keep on rolling here. So now, how far did Cooper go with the wind? That is a long scooter ride. 30 miles, that's more than Maryland. Now, the wind was actually helping her, so I'm going to do the rate plus the wind, and the wind is 3. So I'm going to write it out like that. Now, against the wind, what was the distance? 10. And here the rate's going to be slower because the wind is slowing her down. So I'm going to do R minus 3, because that's the wind, times that. Now, we have two equations. We want to combine these so there's only one. Since we were told that t is the same time, what I'm going to do is I'm going to solve both of these for t. And then we can set them equal to each other. So from this first, when we're going with the wind, we get 30 over r plus 3 is equal to t. And on this other one, we get 10 over r minus 3 is equal to t. Alright, are you following me so far? There was like no response there. Do you have any questions so far? So I've got these two equations, but what did I say was the same in both of them? The time. Now if I've solved them both for time, what I can do is I can set this equal to this. Because if they're both equal to t and t is the same, well then we can set them equal. So I get 30 over r plus 3 is equal to 10 over r minus 3. And okay, that's like the hardest part here is just getting to this point. From here we're just going to solve it and we'll figure out what r is. But knowing how to set that up, that's kind of a skill you need to develop if you don't already have it. From here, I'm just going to cross multiply. I'm going to do 30 times r minus 3 is equal to 10 times r plus 3. And we're just going to go about solving this, alright? So that's 30r minus 90 is equal to 10r plus 30. And I'm tired of talking, so let's send it to Josh Wood. Will you take it from there to solve for r?
You multiply by r? Or not multiply?
Well, so I'm just right here. Come down to this one with me. Let's get the r's together and get the numbers on the other side.
Oh yeah, add the 30, or add the 90.
Get that 90 over here with the 30, okay? So that's 30r is equal to 10r plus 120.
And then subtract the 10r from the right side.
So then I get 20r is equal to 120, okay?
And divide by 20.
120 divided by 20 is 6. Now what does this 6 represent? That's the rate, so we're going to write that miles per hour. This is how fast Cooper is riding when there's no wind. So when she's going with the wind, her rate's increased by 3, so she's going 9. When she's against the wind, she's only going 3. Okay, cool. Now, again, this is just kind of like a fill-in skill. This isn't going to be on your test. It was just something that I forgot to go over earlier with you, so I'm throwing it in now. Okay, do you have any questions on that? Okay, so what I want you guys to do now is you're going to be working on your assignment, okay? What time is it? We only got a few minutes, but go ahead and get started, and then if you have questions, let me know. Next time we're gonna cover finance, and then that means on Friday we're gonna have a review, and on Tuesday next week we're going to be testing. So make sure you, if you have questions, that you come in and get help before after school. Tomorrow's not a good day because we have Building Greater Chances Club. You should come to it. We have fun. And then, yeah. If you haven't seen Mamma Mia yet, this is the last week, right? When's the last show? Is it Friday? Thursday, okay. I'm going tomorrow to see the B-cast because I saw the A-cast. And you're a B-cast person, right? Alright. Fun. So anyway, if you haven't gone, you guys should go. Alright. You guys are awesome. Go to work.